Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So a month or two ago, I sort of jokingly made this cardboard box enclosure for one of the machines that we've used here on the channel. It was the video where we did the 6x6 PETG post caps, and we engraved the front of them with the fiber laser. And I made this for that fiber laser because it didn't have any enclosure at all, and it's not particularly safe to use that way. Well, this ended up being pretty much a waste of time for a number of reasons, because it's not tall enough. I didn't have the gantry raised all the way up when I figured the height of box I needed. I think this was the biggest box I had anyway, so I guess it doesn't really matter. And I've since found out that this tinted acrylic does absolutely nothing. So I went onto Amazon and I started to look what was actually available. And there's an enclosure here from CloudRay, 670 bucks. The reviews certainly don't look very good, and it's got a tiny little window in it. And I don't think this one is big enough either. It's tall enough, but I don't think it's big enough in depth. There's a bunch of these like zip up fabric ones that say multifunction 3D printer enclosure, laser engraver, eye protective shield cover. Yeah, I'm not buying it. I mean, that price is good. And I'm guessing it's probably sufficient for fume extraction, but I can't imagine that window is actually going to do anything to block any of the dangerous reflective light from the laser, particularly a fiber laser or a diode laser. And I wouldn't want to deal with like a zip up door anyway. There's another one here, Com Marker, basically the same price as that other one, also not well reviewed. At least the window's a bit bigger in that. I don't know if that one's big enough. Either way, I don't want to spend that much, and I don't want this to be an enclosure that is just for like a laser. I would like this to be an enclosure design that really you could use for anything. And it's the same thing with 3D printers. You know, if you go with one of those fabric enclosures that has the zip up door, they're not too expensive. You can get one for under 100 bucks. I can't imagine that user experience is very good though. I like an enclosure that is a rigid frame, at least as rigid as this cardboard box, preferably even more rigid than that. And more importantly, has a hinged door, something that I can open and close easily without fighting with a zipper on an enclosure that's so light that the whole enclosure is moving around anyway. And those rigid enclosures, even for 3D printers, are quite expensive. The cheapest I've seen them is about 200 bucks, and they don't seem to be made that well either. Now, Prusa has a really nice one for their Mark IV series printers. I guess you could put the Mark III series machine in there as well. But that thing is really expensive, particularly for what you get. And yeah, it's metal, I get it. It's a perfectly nice enclosure, but that's a lot of money to spend on an enclosure. I mean, you may as well just buy a P1S. So I think we can design our own rigid enclosure with an actual hinged door. And I want to design it in a fashion that it could work for anything. You could build this same enclosure for an A1 Mini, or you could build it for, say, a Neptune 4 Max. You just change the number of components that you have to print out and the size of the panels that you have to cut out. So let me get this out of the way, and I give you kind of an idea of what I'm thinking about. All right, so I think the trade name for this material is Coroplast, although that is probably a specific brand, maybe even the brand that originally launched this material. I don't know. Someone that knows signs really well will probably let us know down in the comments. But this stuff is just a thin corrugated material. It's about 4 millimeters thick, solid layer of plastic, a corrugated section, and then another thin solid layer of plastic. And it's very lightweight, and it is very inexpensive. In fact, it's often free, as this piece was. There was just a pickup truck going up and down our street this summer, sticking these on like every third yard, and as soon as they disappeared, I went and took the one off my yard because I'm not a fan of just giving people free advertising on my yard, and figured I could use it for a project. I'm going to get some of this material without markings on it before we finish this project, but I happen to have this one laying around. Don't call this number. I have no idea who these people are. I'm sure it's a fly-by-night operation. There's no brand or anything on here. It's probably already disconnected. But just to be clear, I have no affiliation with these people. I don't know anything about them other than that they left a free sign on my yard. So in a nutshell, my idea is to design an enclosure that uses this corrugated plastic material as the sides and the top, and design all the rest of the parts to be easily 3D printable and sort of go together like Legos. So imagine if this is the front of our enclosure, or we'll call it the side here from the perspective of the camera. So we can cut this material to be whatever height we want, whatever depth we want, and we could design 3D printed parts that interlock together to build up the corners and the top and bottom of our enclosure. And we can essentially make it any size we want. This stuff is easy to cut, and certainly we can design in 3D print whatever size pieces we want. And yeah, everyone's probably going to be limited by different size printers, particularly in the Z height for printing like corner pieces. But you can go with smaller ones and connect them together. Nothing says you couldn't do an enclosure that is several feet or several meters even in width and or height. You're just connecting pieces together. So I think as a proof of concept, the first thing I want to do is kind of try and design sort of one piece that goes on the edge that would either be a side or a top or a bottom, and that slips over this material, and just kind of get an idea of how this looks and how it is going to fit together. I know the corners are probably going to be fairly complex to design, so I don't even want to go there until we know that this idea is going to work. Basically, I don't want to get carried away doing a bunch of 3D drawing if this idea is no good. So let's start simple. Let me design a piece that just sort of slips over this and get an idea of how that fits, and if it just, I don't know, seems like this is going to work. So we can do that. I'll bring you back. All right, and here's the initial design I came up with, and this is pretty simple. We've got slots down the side for that corrugated plastic to slip into, and this hole down the center, I'm not entirely sure if we're actually going to use this for anything. My thought is it gives us the option to pin these together in the future if we want with something, and I think it's actually going to increase the rigidity here at the corner as well, because we'll have those extra walls of printed material in a direction that is different than the direction of the other smooth faces here. And this detail down the side is purely aesthetic. I just figured that that would look nicer on the corner versus this just coming to a point. I think that might also make it easier for these to meet when we ultimately design the corner piece as well. So I'm going to stop here. I'm going to print one of these out and just see how this actually slips over that corrugated plastic material. All right, and our test piece is done, and it looks like it came out nice. Let's see how good of a fit this is. Oh, it actually fits. Yeah, it fits good. See, it's not moving around. It's also not so tight that it is pinching it and deforming it. Try it on this end. Yeah, I'm happy with that. All right, so you know what? Let's just see. I'm going to just kind of try twisting a little bit with this. Yeah, I think that's going to work. I was a little worried that we'd have to go wider on these. I wanted to keep these as basically as small as we can. Certainly this would be even stronger if this slot was twice the depth, but then we are significantly increasing the amount of material that we're using to create the frame. And I'm trying to minimize the amount of actual 3D printing and maximize the use of just cheap, easy to get material like this. So I think that's going to work. I think the next thing to do is to start thinking about how these are actually going to interlock together. I think the obvious answer is one of these sides has like a recess in it, and the other side is raised, and they just kind of key together. So got to wrap my head around the way that I want to do that. And yeah, let me do that. I'll bring you guys back. All right, and here's what I came up with that for kind of a first try. So I think it is going to be just as easy as having a raised section and a recessed section. I'm not entirely sure how this is going to print, so I'm not going to make a bunch of them. I think we'll just print maybe 2 and see how they come out. I think I'm going to print this face down, and I'm hoping that this bridges across here. I've raised this up so that even if we kind of have a bit of a mess, it should be okay, because I think it's going to matter more that this raised part and these edges here are all nice and clean, so we'll have that print as the top. All right, I'm going to hit print. Let's see what we end up with. All right, I printed out 2 of these. I didn't really clean them up. I didn't bother like deburring them or anything like that, because we really only need like one of these faces and one of these faces to try. Yep, they fit together nicely. There's no real movement there to speak of, so I think our clearances are right. I don't like the way I designed this part. I recessed that far enough up there that I figured I just didn't really need to worry about supports or care about the bridging. But the way that it printed it, it didn't really bridge it. It tried to essentially print the first couple layers just completely in midair. It didn't bridge across just due to the way the geometry works. So I think I'm going to actually decrease how much that's recessed, like bring that back up flush with the bottom of the sloped part, and just print that with supports. That'll come up a lot cleaner because they're both pretty messy. And screw holes came out good. I think that's going to work well. I did order a whole bag of hardware. Hopefully these are the right size. I got ones that had like a recessed hex head with the hope that we can put all these in with the T-handle wrenches and they should look pretty decent versus having... I'm not a big fan of the way that like the flathead screws look. I prefer the hex head. You can feel that firming up. And it should be flush if I got the measurement right. Yep, that is like right there. I can just feel it just kind of just kissing it a little bit as we go over. I set the depth on this and the length of the fastener that it basically sits just flush with that face on the material. And I think it is just biting on this other side, which is perfect. We'll have to actually try it on the Coroplast as well, but that should work. So let's back this out and actually try putting this on the plastic. Might be tough to get these started. Kind of hoping I can stab it through them. I have more use of this hand now, but I still can't really push on things with the force that I would like to. Yeah, I can rock it back and forth a little bit, but that's... I think it's pretty good. I don't think that's going anywhere. Yeah, there's our hole in the Coroplast. It doesn't look like it was starting to tear out. So I think that's good. And I mean, that's one piece. We'll have screw holes every, I don't know, maybe every 80 millimeters at least or something like that. So, all right, well, this worked out pretty well. I think it's time to actually go think about designing the corners. That's going to be tricky because we have one set. So if this was here's our first test piece. If this was the corner, not only does it need to receive this, it needs to receive the piece going up the side, and it needs to receive this. And I think we're going to need, I'm getting ahead of myself. All right, I'm gonna go start scratching my head and drawing, or trying to draw those corners. You know, that's the thing with projects like this that have a lot of complexity and a lot of different things you need to design. You really need to take it one step at a time and start with the easy parts first, particularly if the easy parts are going to give you an advantage when you get to designing the harder parts. So I knew the corners were probably going to be the most difficult part of this project to design. But now that I have, you know, some samples here of side pieces that are working, I can reuse a lot of the geometry that I used to create these in those corners. And yeah, I'm still gonna have to wrap my head around what's gonna need to connect to what as we work sort of around the square shape of the enclosure. But I have a much better chance of success within the first couple of tries, having gotten at least this far with the side pieces first. It's like, what's the old saying, you know, how do you eat an elephant? One bite at a time. All right, I'm gonna go work on those corners and I'll bring you guys back. All right, here it is. And this took a while to draw. There was a couple times where I pretty much thought I was there and realized that I was gonna have some interference that I just hadn't thought through. But I think this is it. I'm pretty sure that this is gonna fit with our side pieces and should allow us to reuse the same corner piece all the way around for the top or the bottom. One thing I struggled with was exactly how this was going to print. I think I'm going to be able to print it just down on this face. It's not going to give us a lot of surface area, but we can put a brim on it if we need to. So yeah, I could spend a bunch of time trying to explain what I was thinking with this, but I think the easiest thing to do is going to be to actually just print one and see if it works. So let's do that. All right, first corner is done. And one thing I didn't really consider, well, I did think about it towards the end of designing this piece. I wish I'd thought about it earlier in the process. I went out of my way to recess these in such a fashion that would have plenty of clearance to compensate for the support interface if we needed it. And the reality is I ended up actually being able to just print this on the corner. It stood up on the bed. I don't know if I can get it to stand here up on the workbench. Yeah, like that, which means this printed with 0 supports. Now, I'm glad I stopped at the 1 because I can now go and undo a lot of the things I did in the geometry here to try and leave space for the supports. Like I'm going to bring these faces, bring this inside face up closer to this outside face on both these sections. And while I'm happy with how we printed on the corner, I don't want to get caught up in aesthetics, but I just don't really like the way that that corner looks. So I'm going to think through a better way to sort of design the corners rather than just have this flat face here. But let's try it. So we've got two pieces here. So let's see, which face do I want? I think I had figured on the face. Yeah, it's basically going to have to go this way with this face here. So if you think about it, if this is a recess here and this one is going this way, as we go around in a circle, so kind of just use your imagination here with me. This one's not going to lock in because I still never cleaned it up. But pretend now we are at this corner over here. So if I take this piece and I swing it around, now it connects on this way, and now we have the male side here. So if we swing these around, you can see that's going to lock on there. We should be able to go all the way around 360 degrees to have 4 square corners with just this corner design. Now, I'm not sure that's going to work for the top and the bottom. Got to think that through. I guess it depends on how we do our middle pieces. I think we would end up with a middle piece that needed either 2 male or 2 female, I guess depending on how we had this position. I think 2 female. Getting ahead of myself again. So I think I'm going to go ahead and make those changes to this corner design and print 4 of these out and just see if everything I just kind of imagined there is actually going to work in reality. All right, printed 4. And I'm much happier with that for the corner. I just sunk it in further so that we end up with kind of a neat little geometric shape there on the corner instead of just that guy there. Yeah, I think that, at least to my eye, that looks a lot better. I also added the screw holes for these as well because we're going to need the corners to lock in. I may end up gluing these pieces together. There's one of our good side pieces. So I may end up gluing these joints. But I think the majority of the strength is going to come from the corrugated plastic, because once that's inserted in here, once we have a screw here and here, that should hold it fairly tight, particularly once the whole thing is built. If that's not enough, we can definitely glue these. We'll have plenty of surface area to glue these, but we're not going to want to do that until we have everything basically dry fit for the entire enclosure. So I think in theory, we should be able to basically build a bottom or a top with just these pieces, I think. So let's see if I orient them. Yeah. Yep, that works. So yeah, I guess that's the smallest enclosure you could make, but you couldn't get into it if we had another one of these. And yeah, I can see for sure already. So if I printed 4 more of these, they wouldn't connect together. I think we'll probably have to design well, I guess this would probably be the top. We might want a different design for the bottom anyway, because we might want to put some feet or something on it. So we'll call this the top. Let's try connecting some pieces in here. We got 2. So nope, that's wrong. We need this space to be going that way. Yeah, these definitely don't fit together tight enough that they're going to stay. And we still didn't clean that up. Let me just deburr this quick. All right, that should be good enough. Maybe. Yeah. And we'd have our corner. Oh, I keep putting them on the wrong way. It's going that way. Yeah, that should work. So I think the next step is to basically just design some longer versions of these sections, at least long enough that maybe we could cut a piece off of this and try it. So, all right, I'm going to go design some longer versions of this piece, and I'll kind of think about how I want the screw holes spaced out as well. I don't know if I'm going to try and standardize that, because we're going to end up with all different lengths of this. That's the idea, is that you should be able to make one of these style enclosures for any size machine. Again, whether it's like an A1 Mini, or the mini prusa printer, or a huge bed slinger like the Neptune 4 Max. and still be able to have a heated chamber, or for a fiber laser like what I'm hoping to be building this one for. So I'm going to go draw these. I'll bring you guys back. All right, I printed 4 of these to get us started. And let's see, we're going to need, let's get rid of the old stuff here. Like, we don't need that. We don't need that. We don't need, I guess actually we do need the rest of what's here. So, all right, let's build like a large base, I guess. So I think the thing I need to remember with these is this never faces up. As long as I face this like this, or I guess even like this, and work my way around, we'll always be okay. So never facing like that. So, all right, so if we take that, back to that. Like that. One more corner. Yes, that is the right style. And I'm going like this. Yeah, it's going to go together. All right, that's all fitting together great. However, this has no real strength. Like if I just push from the corner here, you can see that it's going to come apart because these don't stick together that tightly. We're really counting on that corrugated plastic to essentially hold all this together. So I think what we need to do is to figure out what size piece of that we would need to fill this bottom section here, and put the screws in from the other side and see if this guy is actually going to stiffen up. Because once that's in place, this should be plenty strong enough to pick up and move around without it falling apart. So I think that's our next test before we keep going. All right, so once you've marked and measured your 187 millimeter square, immediately realize that you needed 287 millimeters, and then cut it all over again. I don't think I'm going to put any screws in until I have it all together, just in case I cut this a little bit too big. Tell you what, even without the screws, that's actually holding it together really nicely already. And last one. Okay, yeah, even without the screws, that is really good. And hopefully you guys can now kind of get the idea of where I'm going with this. I mean, the enclosure could be just this size. We probably wouldn't need much bigger than this, cubed, for like a very small 3D printer. But the idea now is to go ahead and build out the rest of this. But let me get the screws in first and just see how much this tightens up, because as I'm knocking this around, it is slipping a bit, but not much. And you know what? I wonder, might be worthwhile putting clamps on each side as we tighten it, just to make sure everything is nice and snug when those screws go in. Because once the screws go in, we're never going to get these gaps to close up because we'd be pushing against the fasteners. Let me grab some clamps. Like ½ inch too short. All right, that is now nice and snug. So I'm going to put these 1, 2, 3, 4, 5 screws in. Yeah, tightening it up with the clamp really closes those gaps up nicely. Well, aside from that, I didn't deburr that well enough, but I can see the gaps closing up. So I'm going to do this side, then we'll switch the clamps over to these two sides, and we'll see if the whole thing stays tight. All right, putting these in with the T-handle wrench, particularly the ball end, since it slips in these shallow heads, is getting a little bit cumbersome, particularly with the wrist. So I remembered I have a set of these hex bits like this. This is 2mm. And I have this guy here. This is a Vessel little electric screwdriver. Doesn't have enough torque to put in like a screw into wood, but it's good for stuff like this. Not sponsored. This was a gift from a good friend of mine. Let's see if this will put these in. This, I think, might fall into that torque category where it has enough oomph to do it and will probably stall out once we get these screws bottomed. Yeah, I think it would probably go in a little bit too far if I kept going, but way easier than the T-handle wrench. Oh, and Mike, if you're watching, thanks for the gift. I'll tell you what, function over form, but these screws actually look really nice. I'm really happy with that look. It has sort of almost like just a neat mechanical look to it. Yeah, I mean, I can flex it, so if I grab like here and here, I can create a gap up here, but that will be held in place once there is a panel in here and it's screwed into these two. But I don't think we're going to need to glue these. I think even if these sides were constructed from multiple pieces, which they're going to be in our full-scale one, I don't think we're going to need to glue it. This is really sturdy. Like, this had no strength at all. You saw on the bench, I mean, just pushing from the corner collapsed the whole structure. And now it seems really tight. You know what would be a good test? Let's drop it. Not from real high, but high enough that you know this guy's going to experience some force. All right, so what would be the worst case scenario? Probably dropping it right on the corner, right? Because that's going to try and cause this whole thing to collapse. This end's going to try and get closer to this end. Let's try it. No, it is still really tight. Try a little higher. No, I think it's still, I thought I was seeing a little bit of a gap there, but no, it's still really snug. Yeah, I think that's going to work really well. All right, there's no chance we're going to get this entire enclosure done in 1 week. It's just way too much drawing and printing to do, particularly with that door. I know that's going to be complex. But what I do want to get done this week is figure out the opposite corners, because I think we're calling this the top. Because as a reminder, if I grab, let's see, yeah, we can use one of these. So if I was to put this guy here and pretend that this was the whole length of our side, you can see if we had another corner here, this would be the face of that corner that we'd have. So we'd have basically two female ends. That's not going to work. So I think the easiest thing to do is just going to be to design a second corner that would be the bottom. That also gives us the opportunity to put maybe a spot for a foot on our bottom corners. The other way we could solve it is if we had a centerpiece that had there'd be two female ends. In fact, I guess we could still use a number of these. We would just have a piece at the end, or really it wouldn't matter. It could be in the middle too, because you could flip one of these around. So our piece with two female parts could be in the center, and then we'd still end up with two female ends on either end to go into the corner. But I think I would rather just have the separate corners, again, because that gives us the opportunity to customize the corners for them being the bottom. And then we can keep all these the same, where on one side they're male, one side they're female. I think I'm going to need to draw it and make sure that that actually works, and I'm not just imagining it that way. So I'm going to go draw it, and I'll bring you guys back. All right, probably only needed to print one, but I printed 4, and actually I had to change the way I was printing these. If you look, you can see here. So this first one printed fine, and I figured it would because we printed all 4 corners of this one, just stood up on the corner, and then the next one failed. It got knocked over. And I thought, okay, it's a fluke, no biggie. And I printed another one, and it got knocked over. And then I repeated the stupidity and printed a third one, which also got knocked over. At that point, I realized, no, something's definitely different. I think it's this divot here. I think this bridge here, just the angle that is, if you can see that, I don't know if it's focusing on it. The angle that this recess is, that bridge, I think the nozzle was hitting it and knocking it over because it was always kind of around that area. It never got, that's also why I stubbornly tried 3 times, because it's not like I was printing the whole thing. It was only reaching kind of around to this point and then failing. So that is why the texture looks different on this one. I just added a raft. I can't even remember the last time I used a raft in 3D printing, but that actually worked out better than doing a big brim, because with the raft it still peels off and you don't have to try and deburr that, and I did not want to try and deburr all those little angles in there. Yeah, the surface finish isn't perfect, but yeah, it wouldn't be perfect if we did the brim and deburred it either. We'd see all the oddities and trying to clean those different angles up. So I think I prefer that, but when I made that change, they all printed out just fine. So now, if we take one of our, we'll put 2 on here. So imagine that that is, again, this is the top, so this is actually upside down. This would be the top face here against the workbench. This would be our bottom corner, and we still need to have male on one side, female on the other side, so that it connects all the way around. But we want the second female face, because this now has one female face and 2 male faces. So if I position it like this, yeah, that's the ticket right there. And I didn't do such a hot job deburring that or the piece under it, but now we could use these same pieces that we have down here to go all the way around, because we're male here, female on this side, but it locks into our side piece with the second female side there. And the idea is, oh, I still had it, wait a minute. Did I do that? No, it goes this way. There we go. Yeah, so our male is this way, female is on this side, and this is the face that's down with the indent here for the optional foot. And I might put 2 recesses in here to press magnets in too. I guess that's only going to be useful if you're putting this down on a metal table, but I'm going to be using this for that fiber laser that's not enclosed, and it's actually on a metal workbench. So just standing here thinking about it, if I was to press 2 neodymium magnets in here, that would be a total of 8 magnets on the bottom of this. That actually would probably hold it in place on the workbench instead of it sliding around, because I think this thing is still going to be pretty light. I mean, this is starting to have some mass to it just with these pieces, but the bulk of the material, again, is this corrugated plastic, which weighs next to nothing. So, all right, guys, well, I think I'm going to stop it here for this week. I mean, we could print more pieces and play with this further, but at this point, everything is proven to work. So I think it's now just a question of actually figuring out how long all these individual pieces need to be to get to the total size to enclose that machine. Let me show you what machine I'm talking about. And this is that machine I'm talking about. This is a 30-watt mopa fiber laser from Monport. Happy with everything this machine does and its performance, not happy with the fact that it is not enclosed. It's really not safe to use a machine like this in an open shop environment. I think in an industrial setting, they probably have like stalls or shielding around them, or maybe they're even in a room that's limited access. I don't know. But in a hobbyist shop like this, you really want an enclosure for the machine. You don't want someone walking in, particularly on a longer running job. I mean, if this was engraving for half an hour, you gonna stand here, babysit it, and watch the doors for 30 minutes? No, probably not. So yeah, I don't want my wife or kids to walk in and, have laser light bounced off whatever I'm marking or engraving and potentially cause eye damage. All right, guys, as always, thanks for hanging out in the shop with me for this week's design and prints. I know this is just kind of the start of this, but I think we made good progress. I'm really happy with where we're at so far. Next week, my goal is to get all of the rest of the parts for the enclosure itself designed. And maybe we'll get to the door, or at least we'll get a start on the door. I don't want to get ahead of myself. I know that door is going to be fairly complex to design. I really want a solid hinged door with a nice handle and magnets that are going to keep it shut, or some sort of like ball detent or latching mechanism that are going to keep it shut. If this is your first time here on the channel, this is all we do. It's all functional prints. A lot of stuff out here in my shop or to improve the 3D printing or just general making experience, but a lot of stuff outside and around the house as well. So if you're into that more functional side and engineering, part of things, check out some of the other videos on this channel. If you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.